Now let's try to create ND arrays in different methods. So there are several ways to create arrays. So for example, you can create an array from a regular Python list or tuple using the array function. So the type of the resulting array is deduced from the type of the element in the sequences. So let's do that. So I'll put array creation. So first array creation from Python sequences. Okay, so as import the numpy has been imported, so now let me create array 1. So a1 np, and I'll use array method from the np, and inside that I'm gonna use Python sequences. I'll use a simple list. So 1 comma 2 comma 3, that's it. And let me execute it and say a1, and here is your array. So it's an array 1 comma 2 comma 3 comma 4. Just want to cross check. A1 shape, it's a 3, and A1 end obviously it's 1. We know that. And elements, it's a 3 elements, and you have a 3. You see that it consists of only one axis. Only one axis it consists of. So this is one way of creating. If you want to see the D type, and we'll see what's going to happen. D type, it's int 32. By default, it took int 32. Okay. So now I want to create a one more array. So this time I'm going to use floating numbers and see what's going to happen. So I'll say array float1 af1 equals to np dot array method I'm gonna use, and inside that I'll put a list of elements saying 1.0, 2.1, 3.2, and 4.5, and execute it f1, and here is that. You got that, an array with floating point numbers. Let me check with the t type. So t type says it's a float 64. You see that it got float 64. Now float 64 by 8, each element in this would be 8 byte. Let me cross check. Af1 dot item size, and here is that, hence proved. If we do it for this a1, I think it's sorry, it should be a1, sorry, a1 a1 is also int 32, so it would be 32 by 8. It should be 4. Let me cross check that. A1 dot item size, and it's 4 bytes. You see that it's a 4 bytes, just 4 bytes. Okay, so this is one way. Let's see more ways. So a frequent error consists in calling array with multiple arguments rather than providing a single sequence as an argument. So let's take one more example before we go to the other one. So let's take A2 this time, and np dot array, and inside that I'll put just 1, 2, 3, 4, four arguments, multiple arguments, and let's see, execute and see what's going to happen. So it has thrown an error saying array takes from 1 to 2 positional arguments, but 4 were given. So it will take only 2 positional arguments. That's it. So first positional argument should consist of a list of items. This is a wrong way of doing. So this should not be done. So its first positional argument will consist of a list and second positional argument will consist of a D type. So what type of element you want to include in your array? But here, so this is not the way. So now we will do it in a different way. So what I'm gonna do is a3 np dot array, and inside that I'll put the same values as a Python sequence 1 comma 2 comma 3 comma 4, and execute it, and a3, and here is the magic. So that's what you have to be very careful. You have to put the sequences, not the objects. Okay. So now the second way of doing array, the second way of creating arrays, ND arrays are array transforms sequences of sequences into two-dimensional arrays. So sequences of sequences of sequences into three-dimensional arrays, and so on. If not clear, you just read it here. So what I'm trying to say is array transforms sequences of sequences, if sequences of sequences into two-dimensional arrays. If you have sequences of sequences, that means three sequences, it will be turned into three-dimensional arrays, and so on. If you have sequences of sequences of sequences of sequences, that's a four sequences, it's a four-dimensional array. I hope you got the point. Let's do a practical demonstration. Okay, I'll say creating multi-dimensional arrays. Simple. So let's take so MA multi array. So so multi-dimensional array MDA. So let me NP and array, and inside that the first argument should consist of a sequence of sequence. So I'll put a list of lists. Okay, got the point? I'll put the list of lists, a sequence of sequences. So 1 comma 2 comma 3, and second one is again 3 comma 2 comma 4. Okay, and let me execute it, and MDA, and here is the magic. Here you got the multi-dimensional array. Clear? So if you want to check it, MDA dot shape, it's a 2 by 3, and the length would be MDA, it's a two-dimensional. So let me check ndim, and here is that. It's pretty simple. Okay, so now similarly you can use a list of tuples. You can use a list of tuples, still it works. Okay, a list of tuples. The type of array can also be explicitly specified at creation time, that we can do. But before that, I want to give one more example, but this time it's a tuple MDA1. So I'll take NP, sorry, MDA and NP dot array. Okay, let me copy this and paste it here. So instead of list, I'm gonna go with the tuple inside. A list of tuples. In spite of all ints, I'll go with some float. some float elements. So 2.5 and 3.3 and execute it. Okay, done. So let me call, let me change it to MDA1 and MDA1, and here it is. You got it? Now let me check the MDA1 D type, what we're gonna get it. It's float 64, because if you have one float 64, that's more than enough to make all others as float 64. You see that all become float 64. We gave int, but it became a float because of we have some floats. Okay, so the next way of creating ND array is the type of array. In that, the type of array, so we can modify the ND array. So the type of array can also be explicitly specified at creation time. So let me do that for you. So specifying data type or D type explicitly. So 3, and this time I'm gonna take one example. So let me take so comp array. So np dot array, and inside that again I'll take a list of lists. So not to complicate, so 1 comma 2, a simple ints I will take, and 3 comma 4, and here, so one more argument I'm gonna put it inside. That is going to be our data type. That's what I was saying. So D type. Okay, so this is correct, a list of lists, and after that I should have a D type. It's a complex, I'll go with the complex one. Yeah, you got some compile or complex, I'll go with the complex one, and let me execute it. And now let me call compa, and here is that. You see, you got that, a complex numbers array, a complex numbers ND array. So often the elements of the array, so can be often the elements of the array, normally we do that type specification. So we will do that type specification sometimes. You can use this D type argument to do that. So let me do compa dot D type. Anyway, we have mentioned, we should know what it is, but let's just to cross check. Okay, it's dompa. That's not the case. Comp, and it's a complex of 128. Oh, it's huge. Let's check the item size. So compa dot item size of 16 bytes. It's huge. It's huge. Okay. So now often the elements of an array are originally unknown, but the size is known. Hence, NumPy offers several functions to create arrays with initial placeholder content. So these minimize the necessity of growing arrays, an expensive operation. So one that kind of method is the function zeros. If you use zeros method, creates an array full of zeros, and similarly the method ones create an array full of ones, and the function empty, if you take the empty, creates an array whose initial content is random and depends on the state of memory. So by default, the D type of the created array is float 64, but it can be specified via the keyword argument D type in our array method. So let's do that. First we will do the function zeros. and then we'll go for the ones. So function zeros, or I'll say method zeros. Okay, so here it's pretty simple. Np dot I'll directly use zeros. Let me look for that. Argmax zeros, and inside the argument we have to mention inside this we have to mention the tuple argument. Okay, we will give an argument which is a tuple. So how many rows you want and how many columns you want. So that's what we want to mention. Inside that we have to mention the tuple. Okay, so I'm gonna give 3 rows, that's n by 4, 3 rows and 4 columns. Clear? So 3 by 4, n by 4, 3 rows and 4 columns. So now let me execute it and see. You see that the magic array and all our zeros with 3 rows and 4 columns. So now what I'm gonna do is I will do few more things. So let me do shape. It's a 3 by 4, and let me look into the D type. It's a float, hence prove the point that I have said before, and as usual rest remains same. This is using zeros. And similarly we can do with ones, a method ones. So here we'll take np dot ones, and again we will be having a tuple, the first argument as a tuple. So how many rows you want, how many columns you want, and additional information. That's the ones. All will be ones, all will be ones. And if you want to mention a D type, you can mention the D type also. Let me give the first argument, that's a tuple. So 2 comma 3 comma 4. Okay, that's what my initial argument. Then second one is I'll go with the D type and np, and in np I'll go the simple one, int 16. I don't want floats, int 16. And here is the magic. You got it? So it's a 3 by 4. Two I want two arrays. It's a single array of course, but I want two 3 by 4 arrays inside that in a single array. You can see that 3 rows and 4 columns, 3 rows and 4 columns, but you got the 2. Okay, and obviously D type is hint, that's what we have mentioned. And similarly we can do it for the other method. It's called empty. So let's do it for that also. Let me show you first. So the second one is empty, the function empty. For that also we're gonna do now. So let me mention method empty. Yep. Okay, so np dot empty, and again the first argument would be tuple. So I'll directly say 2 comma 3 or 3 comma 2, whatever the way you want. Here it is. So it randomly creates what is an empty. Let me reiterate. The function empty creates an array whose initial content is random and depends on the state of the memory. That's what had happened here. So let me refresh it and again rerun it. Now one more. So I'm going to create one more this time. So np dot empty method, sorry, not emat, empty method. So I'll say one row, sorry, I'll go with the 6 rows and 2 columns. And okay, something is wrong, sorry I gave too many arguments. I have to give only one argument here. That's a tuple argument. I had to close the, yeah, yes, here is that. Clear? It randomly creates, it doesn't matter, like sometimes it creates something and sometimes some other thing. So np dot again empty, and this time I'll go with the 2 by 3. tuple. I have to attach a tuple inside. And here is that. You got the 2 rows and 3 columns method, 3 columns array. And what's the dimension? How many dimensions it has? Ndim, it's 2 dimensions, and it's clear. You can see that it's a 2 dimension. Yeah, that's what. And more ways to create. We have a few more ways to create. Like when. So to create when arrange, let me look into the range option now. We'll use a range option to create a sequence of numbers. NumPy provides a range function which is analogous to the Python built-in range but returns an array. So that's why it's called as a range or a range, an array range. Let's use this one and let's try to create an array, ndarray. So create using arrange method. So let's take one example for now. So np.arrange, and so I'll take a range directly. I'll mention, if I mention the elements, I have to give few more things. For example, 15, and then I have to give a shape. And inside the shape, I'll give 3 by 5. So a tuple object is not a callable. Arrange. Let me give the tuple object inside that. So directly, let me give an argument here. np.arrange. So example, I'll take 1 to 10, and I will put 2. And here is that. It's a 1 dimension. Let me check the dimension. ND. So ND, it's 1 dimension. Clear? If you want more dimensions, you have to mention a shape. Okay? So you can make it with the floats also. np.arrange, and I'm gonna use 0 to 5, and I'll put 0.5. Sorry, here is that. So 0, 0.5, 1.1, 1.5, 2, 2.5. So we got, let me check, the shape would be 1 axis and size would be, yeah, 10. It consists of a 10. Obviously it will consist of a 10 only. Clear? So that's how we use arrange method to create an array. So now we have one more method. So when arrange is used with a floating point arguments, it is generally not possible to predict the number of elements obtained due to the finite floating point precision. For this reason, it is usually better to use the function line space, so that receives as an argument the number of elements that we want instead of the step. So let's do that. So using line space, okay, let's take np. So we have to import one more thing for to use this from numpy. You have to bring a specific module. That module is called py. So I brought the py to my system. So now I'm going to use np dot linspace. So linspace would be 0, 2, 9, and execute it, and here is that. So now we will get the exact number how many you want. So let me give a size. Okay, you see that the 9 that you have mentioned here is exactly, you got it. Oh, okay. And similarly, you can do for the pi values also. For example, it is a bit complicated mathematics. Np dot linspace. Let me click linspace. So that's the reason we call the linspace, because we want to use the pi. So that's the reason we call the linspace. Sorry, that's the reason we call the pi module from the numpy. So I'll go with the 0 comma 2 times pi. So pi we just brought up, and then 100 and 100. So let me execute it and see the x, and here is the result. See that? So from 0 and a pi 2 times pi, so it's been 100 values you got. Yeah. So these are all different ways of creating our ND array. So example, array zeros, zeros like ones, ones like empty, empty like arrange linspace, numpy dot random dot generator dot rand, numpy dot random dot generator dot rand, randin. So from function, from file. So all those different ways or different methods that can also be used to create ND array. So I would like you to explore all these additional methods which are available to create an array.